Screen recording software just doesn't seem to like me this week. But seems to have started recording. So, single point. I made one with a big table in it, lots of points, and I thought, sod that, and deleted them all and left just this one. It used to have target number, and it had whole columns of them that were automatically starting at 20 more than this, and all ones down this column were automatically one more, plus one each time, and it had all kinds of stuff, and I thought, sod it. So you just have one target, that's fine. Where it says X right, Y up, Z forward, I am clicking with the mouse, or whether you can see the mouse cursor or not, I don't know. Those are just labels, just to tell you what goes in these three spaces well below them. Over on the right, camera elevation angle in degrees. I have put in 0.5 in cell F2 here, because 0.5 is the same setting as I used. Maybe it helps if I zoom in far enough that the mouse cursor becomes a little hand. You can probably see it then. 0.5 degrees up is what I used for the Blackpool and Lake District skyline calculation. Numbers from which I still have in a text file. F3 here is simply F2 in radians. It's a thing that Google spreadsheets can do. Then we have a single target here, which has Cartesian coordinates, and the example shown is 9.5 meters right, 3 meters down, negative 3 meters up, and 253 meters forward. Or it's 9.5 inches right, 3 inches down, and 253 inches forward. It doesn't really matter. This is a line of text, angles right up. It is just telling the user what the next lines refer to. In radians, this number here. This number here is the angle in radians, which has a tangent of this number down here. And I've just realised that these two numbers are wildly different and something may have gone horribly wrong. And then beneath you have degrees, so that if you want to plot the position in degrees, well, you have it here. 2.15 right, 0.679 down. Then we have photo coords. Because a camera, whether it's literally camera obscura, a dark room, a tent with a small hole in one side, or a box brownie, or a 35mm like an F55, or a modern DSLR of some sort, Canon D500, or is that Olympus? They almost always project the light onto something flat behind, whether it's a flat wall of a room, the flat opposite side of the tent, a flat sheet of cellulose impregnated with light-sensitive chemicals, or a flat light-sensing chip. Which means the position it's going to, where that light ray coming through the center of your pinhole or lens or whatever is going to hit that back wall, or light-sensitive chip, or whatever it is actually the distance behind the pinhole of lens stack or whatever, times the tangent of this angle. This is the angle from the object to the center of the pinhole or single lens, but light through the center of a single biconvex lens, as used in single lens reflex cameras with no zoom, continues in a straight line. Now, most of our cameras don't have a single lens because they have multiple lenses to try to minimize chromatic aberration, or they have multiple stacks of lenses to allow zoom and minimize chromatic aberration, but in principle it's coming out of the back at the same angle as it went in at the front, or at some angle that is proportional to it, and you want the tangent of that angle to tell you the coordinate on the light sensitive back, or the tracing paper on the back of a breakfast cereal package with a pinhole on the other side, which in theory should work, but you might have to be in a very dark room with it held up to a very small hole in the wall for it to work particularly well. So we have two coordinates, and if I can get hold of the zoom thing and zoom in, you can see how these coordinates were worked out. How far the angle to the right. the angle from centre of lens to the right towards this point in the horizontal plane is how far right it is, which is B6, the real coord x right, divided by how far away it is as viewed, get this right, straight down, no, as viewed from the right or from the left at an infinite distance. And how far away that is how far up or down from you it is and how far in front of you it is. So that is, by Pythagoras, the square root, zoom in, get hand, square root of the sum of the squares on the other two sides, the length of the hypotenuse of a triangle. So c6 squared plus d6 squared, square root of all of that, divide how far right it is by that, and you get the tangent of the angle to it. Cell B8 here is simply the tangent of cell B11. Cell C8 is apparently something else. But as you can see, because I also took a screenshot of this one, cell C11 is... that's why they're different. It's not because I messed up, it's because I included cell F3. Right, I can remember what I did. My brain works. Yeah, instead of simply being that ratio, this is the tangent of the angle whose tangent is that ratio, which would be the exact same thing, but there's a minus F3 here, because it is subtracting the camera elevation angle in degrees. If your camera is tilted up slightly, as in this case, 0.5 degrees up, then this thing that was slightly below eye level is going to appear farther below the centre of the view. And something that was slightly above eye level is going to appear very slightly below centre of view. Something that was well above eye level will appear slightly above eye level, and so on. This is why these two are not the same. It's not because I screwed up, it's because I remembered to include a thing, which I forgot that I'd remembered to include. Never mind A. I even described it, and then looked at this and thought, brains. Anyway, you can project. You can do this with a whole lot of numbers from x coords. Really annoying to have to do this. Minus 10 over here on the left. Minus 7.5, minus 5, minus 2.5, not a point in 0 because it would just be a line straight up the centre, plus 2.5, plus 5, plus 7.5, plus 10. Yes, this is symmetrical. Y coords, minus 5 at the bottom, minus 3 on this next line up, minus 1 on this line, just below centre, plus 1 on this line just above centre, plus 3 on this line, and plus 5 up here at the top. So all of these points across the top are at the same height. But because they are distances. First rectangle, the one I just showed the outline of, the one of which I just showed the outline for English teachers, is at a distance of 10 units. This next one is at 23. And then from there, rather than going another 13 each time, I went another 23 each time. So you have 46, 69, nice, 92, 113, 115, for those of us who can do maths, and so on, ending at that number down there, 253, which is of course 11 times 23. The reason this one's at 10, not 0, is that 0 would cause some stupid numbers like 90 degrees and infinity coming out in the answer. Don't need that, doesn't help. If you were to print out this image large enough and paste it onto a nice flat wall, and then stand with one eye closed and the other eye positioned such that your distance from this central point is equal to the length of the printed image from edge to central point, this would probably look about right. You could try putting this very close to your face, try it that way if it's on a phone screen, and see whether it looks right. If you stand well back from this and look at it, it's going to look a bit silly because it's all curved. But if I zoom in, you can see that the central part of this does not look particularly curved. It is still slightly. You can see across here, this upper side of this rectangle and this lower side are both bowed out in the middle, and they're not quite symmetrical because the camera is tilted 0.5 degrees, which causes vertical asymmetry. If you were to compare all these lines, you would see that all over the place. These crosses are in various planes of it. You can see in the very first one I've actually drawn it all the way across. So I've gone from minus 10.5 to 9.55 to minus 9.55 to minus 9.5 to minus 8.55 to minus 8.5 to minus 7.5 plus 5, and so on, all the way across, and here at plus 3 as well, minus 10.3, minus 9.53, minus 9.3, minus 8.53. That got a little tedious. So on the next one, I've done the squares here. So that's minus 10 plus 5, that's minus 7.5 plus 5, that's minus 10 plus 3, that's minus 7.5 plus 3. And I've filled in the outer, it's not a square, it's a rectangle, in each corner. But in between I've just done these crosses, where I have skipped the 8.5 is out here. I have skipped 6, 6.5 and 7, and just done 4.5, 5, 5.5, and 2.5, 3, 3.5 up there. Just gone 4.5 to 5 on the top edge, and the same underneath. So this line of crosses here is at 23 meters, or inches if you prefer, or feet, or yards, or chains, or rods, or furlongs, whatever unit you're using. Along with this line, and then this line exactly lines up with the one at with the outside edge of the rectangle at 46. Oops. And these pluses across here and up here and there, and indeed this one and this one, this one and this one inside are at 46, and then here's the rectangle at 69, nice, which has just edge marks on it all the way around, and it has the outer parts of the pluses there. On this side it has there, there and there, there and there, 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 and there, with a bizarrely shifting accent, all the little pluses for all those intersections. In the left half, on the right half I've left them out to make it easier to see the additional rectangles that I've drawn in, where I've just drawn in the outside and those marks. Which does have vertical asymmetry, but the only places it shows up are that just there, the upper edge has a step in it, and down here it doesn't, because up there it goes across the 0.5 pixel mark, and down here it doesn't. It would have shown up in the length of these little pegs, because they were 3 pixels at the bottom and 2 at the top in a few places, but the next rectangle out in the distance obscured them. So what we've got overall here is that the extreme close-ups are very curved, or make a rectangle look curved in a photograph, but the smaller the angular size of the rectangle, the farther away a rectangle the same size is, the smaller angular size, or the smaller the rectangle at the same distance. If you consider the innermost rectangle of the near one, this one here that's at 10 meters forward, from 2.5 meters left, 2.5 meters right, and from 1 meter down to 1 meter up, it only has the same curvature, well, about the same curvature, as the 46 metre minus 10 to plus 10 minus 5 to plus 5 rectangle, which is kind of similar angular size. Now as they get farther and farther away, they get smaller and smaller angular size. They take up a smaller part of your full field of view, or they take up a smaller field of view, depending whether or not you're zooming in on them. They take up a smaller part of this full field of view, or they take up a much smaller field of view if you zoom in. Yeah. They look pretty much square. When I was plotting these last pluses, those are just straight lines. I think that one has a step in it, just there. This little short line is actually the right end of the right side of the leftmost of this line of crosses. That's where there's a 1 pixel step in that line from this level to this level. But other than that, these were just rectangular. None of these inner rectangles anywhere here has a step in it at all, because they're 1% of a pixel difference from this curvature imposed by perspective. It's making less than 1% of a pixel difference to these rectangles. As I mentioned at the start, I still have the data from a different perspective calculator that outputs in the same units. Outputs the tangent of the angle, which is unitless. And I can use that to replot what I used it to plot in the first place. Blue line, horizon, at sea on the Irish Sea or Morecambe Bay, depending how far away it is. Green line, core, pikes, that's pikes, white pike, white maiden, brown pike, buck pike, dow crag, goat hawes, the old man of Coniston. This single grey pixel is grey friars. Grey friar. This pixel up here is swirl how. Then you have swirl hawes, black sails, red moss something, or red something moss. Weather lamb on the right side. Scarfell, Scarfell Pike Ridgeline, Scarfell Pike, Broad Crag, Ill Crag, all the way across to there, Great End, Esk Pike. This top left is Bowfell. This is Causey Pike, which extends, sorry, it's not Causey Pike, good grief, it's Crinkle Crags, from here up to there, across to there, down to here. This tall bronze column is Blackpool Tower. This shorter one next to it is the War Memorial, and this single dot here is the Mirror Ball on the waterfront. That's their angular size, as seen from Southport. The whole of that picture, the whole of that photograph that got through to Ranty at last, it's about as wide as this, excuse me while I do the calculation, 207 metre away rectangle. From there to there is 10 metres wide at 207 metres. Has a really small angular size, takes up a really small field of view. And that curvature, that apparent curvature, in a photograph of a rectangular object taken from extremely close quarters, well, it's pretty much irrelevant. It's not irrelevant, it's a hippopotamus.